Okay, so this is the second half of, what is it, 4-5?
Yeah.
All right, so we looked at isosceles because the copy room had no white paper, so I wasn't going to walk downstairs, so yellow it was. So we looked at isosceles triangles yesterday, and so today, let's just see what this does, just for chuckle's sake. Looky, there's your Halloween.
That's pretty.
Happy Halloween. So, wait, what does this do? Oh, look at my mummy finger. That's pretty funny. All right, anyway, we're having so much fun here. So, let's look at the new corollaries. So these corollaries relate to equilateral triangles. So the first one says if a triangle is equilateral, then the triangle is equiangular. And why is that? Because if all three sides are equal, aren't all the angles opposite those sides also equal? So that kind of is a no-duh thing, and it's a corollary, which you haven't, I don't believe you've had corollaries before. And corollaries are kind of things that they're not proven, there's not a formal proof behind it. It's not a postulate because it's not something that we've decided that we would do a formal proof to, but we haven't. The corollary is more of a statement of fact. It's kind of a no-duh thing. Based upon what we knew from the isosceles triangles yesterday, if two sides of a triangle are congruent, then the angles opposite them are congruent. This one follows right along with that. If three sides of a triangle are congruent, then the angles opposite those sides. And then the second corollary, if a triangle is equiangular, then the triangle is equilateral. Aren't those converses of each other? So they're really saying the same thing. You use one versus the other depending upon what you've been given. So if I've been given three congruent sides, my conclusion is I have three congruent angles. If I've been given three congruent angles, my conclusion is I have three congruent sides. So it just depends on what you've been given. So for 15, underline the correct number to complete the sentence. The corollary illustrated below is, well, we don't do numbers, so we'll just humor them for right now. But you've been given sides congruent. Your conclusion is that the angles are congruent, so which one is that? 4, 3. So let's look at problem 3. Suppose the triangles at the right are isosceles triangles. So there's 3 of them. They've marked all the congruent legs. Where angle ADE, angle DEC, and angle ECB are the vertex angles. So telling you those angles tells you where the legs are. So that immediately, once you know what the vertex is, you know where those legs are. If the vertex angles each have a measure of 58 degrees, what are the measures of angle A and the measures of angle BCB? So A is right here. I don't know if that's going to show up. Sort of, kind of. So A is right there. And BCD. BCD is this entire angle there. So that's 2 angles together for that one angle for this one. So let's just tear apart the picture. First of all the triangles are congruent by side angle side, aren't they? Because all of the vertex angles have a measure of 58, and that's the angle that's in between the 2 legs. So all 3 triangles are congruent by SAS. So let's just take out triangle DAE. I'm going to put that down here. I'm going to kind of ignore what they're doing here. Let's just take out triangle A, B, B. There's your leg and there's your leg. If I know that this angle here is 58 degrees, what else do I know that can help me get to the answer? Yeah, these angles here are equal to each other because angles opposite congruent sides are equal. And this is the angle I'm trying to find, so I'm going to let that be x degrees. If that's x degrees, what is this one? X degrees. Is it the same? So the equation that I can set up to solve is going to be x degrees plus x degrees plus 58 degrees equals what? Well, that's kind of hard to see. 180 degrees. So what's x plus x?
2x.
So I'll switch to 2x plus 58 equals 180. So then we're going to subtract 58. That didn't show up at all, did it? No. All right, try a different color. How about this? Subtract 58. Subtract 58. And we get 2x is equal to 2, 2, 1. So what does x equal? Divide 12 by 2, you get 6. Divide 2 by 2, you get 1. So x is 61 and x is a full angle, so that's 61 degrees. So that does answer the measured angle A. So therefore, angle A is equal to 61 degrees. Now, look at this one right here. This angle right here is what? Because angle C is comprised of two different angles, aren't they? Yeah. So this angle right here in between the legs is what? Yeah, but what's its measure? 58 degrees. All of these triangles are congruent. Isn't this a base angle, this other triangle? Isn't this a base angle on this triangle? Isn't that what the 61 degrees is? So wouldn't BCD be equal to 58 plus 61? So angle BCD is equal to the 58 degrees plus the base angle 61 degrees, which gives you a total of 119 degrees. So there's the two things that they were asking for. And so I kind of ignored questions 16 and 17. Does that make sense? It's a harder one. All right, so flip. By the triangle sum theorem, oh, we already did all that. So that's all the rest of it. So we can ignore 18 through 21 because we just did all that. So then you do the lesson check. All by yourself. Done yet? You still need more time. So let's talk. So what's the relationship between the sides and angles for an isosceles triangle? Can you check what's the relationship? How are the sides and angles related? What would you tell me about an isosceles triangle? You know about its sides. What do you know about its sides? There are 3 sides. You know anything else about the sides? Isosceles. What makes isosceles special? 2 sides are congruent, and so therefore, what do you know about the angles? Which angles are congruent? That are opposite the congruent sides. Okay. Equilateral triangle. What do we know about the sides and angles? So the side measurements are equal to angle measurements? No. So all 3 sides are congruent, and all 3 angles are congruent to each other. And because you've got 3 congruent sides, those angles are congruent. Okay? So what about an isosceles triangle? It has how many congruent sides? 2. And then the equilateral triangle has 3. We all know that. And then the isosceles triangle theorem states that the angles opposite the congruent sides are congruent. So that one's not so bad. And then equilateral triangles are also what triangles? They're isosceles. So don't forget that. So equilateral triangles are special isosceles triangles. They belong to the isosceles family. It's very similar to the square being a special rectangle, but the square's sides are all the same. So an equilateral triangle is a special isosceles triangle. All sides are equal. And then the last one, the sides and angles of an equilateral triangle are congruent. So go get your workbook. Oh, no, not that. So you're going to turn to page 107. 107. 107. We're going to do questions 5 through 13. You may work together as long as we're working. But I want you to come up with all the values of x and y for 5 through 10 and the values of the indicated angles for 11 through 13 using all of your knowledge of triangles. All triangle knowledge. That includes exterior angles with their remote interior. That includes isosceles triangles, equilateral triangles, the sum angle theorem. All of that comes into play. What? 107, and it's 5 through 13. Yes, we have. Yes. Because this stuff right here is related to previous knowledge. Yep. Yeah, but it's pulling in previous knowledge, so now we're going to pull it all together. just as a little aside, let me get you started a little bit. So as you look at number 5, there are two things occurring here on number 5. This 115 is a exterior angle, right, to the triangle. Isn't it equal to the sum of the two remotes? So if you set up this equation, you've got x plus y equals 115. But we've got two different variables here. Then you notice that this is an isosceles triangle, and these are the legs, so that the sides opposite those legs are congruent. So if that's x, then this is x. So these two form a linear pair. So you can subtract 115 from 180, and you get the value of x, which is 65 degrees. So then we can replace x here with a 65 degrees and subtract that from 115 to get your 50 degrees. So don't forget, we're going to have to now start pulling in all that prior knowledge to get to use the current knowledge as well. So now try 6. 6 is exactly the same way, isn't it? So did we do number 6? Share your answer to number 6 with those around you. Number 6 is just like number 5. What did we get for x?
45.
And for y? 90. You are correct. 45 degrees and 90 degrees. Okay, so let's try 7. 7 should be easier. Yeah, so here's the problem. So let's talk about this one. So here's the problem with this one. An equilateral triangle means all three angles are equal. They're equal angular. So you can set y minus 10 equal to the x plus 5, because now we're talking about angles, right? But you've got two unknowns, so you can't solve that. You could let this one be x plus 5, but if you set x plus 5 equal to x plus 5, all the x's and the 5's drop out, and you have 0 equals 0. Every single equilateral triangle angles are equal to what? Well, added together they equal 180, but separately it's 60, 60, 60. So you have to set each of those separately equal to 60. Right? So now what would y be?
70.
Yeah, so y would be 70. Just 70. And then what would x be? And then x would be 55. And then you could double check and make sure that they actually would equal each other. So 70 minus 10 is 60, and shouldn't they equal 60? And then 55 plus 5 is 60, 60 equals 60. So now try 8. 8 is exactly like 7, right? So now try 8. All by your little self. Yeah. So what did we get for x?
30.
30 and y? 20. Right, so those we can now just bypass and go directly to that they equal 60, right? Now look at number 9. You try to determine, you're trying to find only this half of the angle here. Notice you have a dotted line with a right angle there. These sides are equal. So find y. You have an exterior angle. There are several ways that you could have accomplished number 9. What did you get for x?
70.
These form a linear pair, right? So you could have done that. So that's one way. So what did you end up getting for y then?
20.
So here's one way. This is only one way. I chose to say that the 110, because it's an external angle, is equal to the sum of the two remotes. Well, the two remotes are 90 degrees and y. So I said 90 plus y. So I subtracted 90, got 20. So that was one way that you could get y. Once you got x, you could have gotten y that way also. I didn't get x first. And now that I know y, I knew that x, well actually I could have done x a couple of different ways. I used a linear pair to find my x. What do you know about that dashed line? It's a perpendicular bisector. So if it's perpendicular to the base, it's going to bisect that base and it's going to bisect that angle, that vertex angle there. Although that didn't help us here, but just an aside to you. All right, so then look at 10. What kind of overall figure is number 10?
A square.
A square. So use that knowledge. So isn't it a right isosceles triangles within the square? All right, so find the value of x and y.
That's a really cute joke. This is very, yeah. Olivia has a math joke for you. Okay, you ready?
Okay.
It's kind of stupid. I like it. It's like algebra. Stop telling us to find your x. It's not coming back. Have you heard that one?
Yes, I have. I was going to dress, this was going to be my costume today. I was going to dress as an imaginary number, which meant that I wouldn't be here. There'd be nobody here. Just imagine.
Wow,
But somehow I didn't think that the district would go for that one, so I just showed
I
it.
feel like
No, I wouldn't have had a sub. Miss Murray's imaginary number. Just imagine that she's here. X and Y turn out to be 45 degrees. If this is 90 degrees here, and these sides are equal, the angles opposite those sides are equal, and that leaves 90 degrees left over for those two angles, and you cut that in half, you get 45, 45. The same thing's going to occur over here, because if all four sides are equal, and that's a right angle, that's going to end up being a right angle, so you have the same thing happen on the other side. Now, 11, 12, and 13, find all of those now on your own. 11, 12, and 13, find the indicated angle that's up here. So I want you to do that all by yourself.
Why?
Have you found all your angle measures? And some of you are just chit-chatting.
No, I'm ready to see if I put that one.
Just do it.
I know how to do
I wouldn't have any.
It's Murray. Okay, so did you take no,
I also know.
All right, so let's talk about these.
Oh, that was spoiled.
Okay, so here's my thought patterns on this one. On number 11, the only information you're given would be that these two sides are equal and that, which is a base angle, because it's across from one of the congruent legs, is 45. So you have an isosceles triangle. The angles opposite those congruent sides are congruent, so if that's 45, that's 45. This is the angle you're trying to find. What do you know about those? Don't they form a linear pair? So I subtracted the 45 from 180, and so I got 135 degrees. So angle ACB must be 135 degrees, and it's obtuse, so that makes sense. It's reasonable. Then this one required no work at all. You have an isosceles triangle. You're looking for, oh, I found the wrong angle. Oopsie poopsies. So let's try that one again. Apparently I want to find that angle there. Well, if that's 70, how much is that all together? 140. What's left over for this angle here? 40 degrees, right? And so what do we know happens when we have a perpendicular bisector here? That means this is 20 and isn't that 20? So doesn't this become 20, right? 20 degrees because they want D to B to C, so they want that angle there. So it's 20 degrees. And then for 13, I wrote out a lot more work than I probably had to have, but this was all you were given. You have two different sets of isosceles triangles. That does not mean that this triangle is congruent to this triangle, and visually they definitely don't look that way. But what I do know is that the angles opposite those congruent sides are equal. Well, I knew that one was 55, so that means that that one's 55. I don't know these angles here, so I named them both x, because the angle I'm trying to find was this one right here. So I guess it makes sense I named them x. If these two are 55, that makes 110. And then all together, they should add up to 180. So that leaves 70 left over for that vertex angle. Aren't these vertical angles? So if that's 70, that one also has to be 70. And that's the vertex angle to that isosceles triangle. So what that means is that those are the congruent angles. So I subtracted 70 from 110, or 180, and got 110. And then I divided 110 evenly amongst those two, and that's where you get the 55. So these are the problems I want you to start to be able to do. They're the tougher ones. You got to be able to pull in all that prior knowledge to be able to reason your way through some of these. So questions on that? Yeah. I can do it all day long. All right. It's almost like a domino puzzle, or a domino thing that you create. One domino falls and they all start to fall, but you have to get the right domino to fall. Yeah. All right. So go grab a textbook, put your workbooks away.